Today I'm going to show another own design of a generator coil. Here you can see it. It's a kind of an odd shape, but it's not intentionally. I designed it to be like that. The drive system is still the same. On this side I have a 1.2 watt load and a 5 watt load over here. I'm gonna start the system. And by the way, this coil also has no effect on the rotor, giving a little bit of spin, so you can say it's an air core. No cogging effect whatsoever. Okay, give a little spin, going for first speed. This coil is also going directly to the rectifier and goes to the output panel. I'm going to use the 500 milliamp scale and of course the digital voltmeter. Second speed. Engaging here the voltmeter and the ammeter. As you can see, the coil is already producing some voltage. The load is not connected yet. This one is still not connected. Going for third speed overdrive as usual. You can see the output voltage is climbing. Another look at the coil. It is a coil that uses both sides of the neodymium magnets. When the input reaches around 525 milliamps, then I'm gonna engage the first load. And then we will see how much drag the coil puts on the system by looking at the amp draw increases. Yeah, it's about there. 17.9 volts. Going for the 1.2 watt load. As you can see, the volt has dropped, which is more than normal. The light is pretty good. System is slowing down a bit. Input amps is now is going for 700 milliamps. Give it some time. Volt has dropped now till 6.9. Milliamp output is around 225. Input draw is now 700 milliamps, which is roughly 175 milliamps more with the load. Going for in the dark test, you can see the light is pretty good. 6.8 volt DC output. the input volts. Input is still 700 milliamps. Now I'm gonna go for the 5-watt load. The 5-watt load is lit up. Volt is now 6.2 and milliamp is now 250 milliamps. And at the input side, it is a little bit more than 700 now. Say 700 and 715 milliamps, just a little bit more, not much, but it's still there. Output 6.1 at 250 milliamps. Test in the dark with a 5-watt load. Output voltage and the input. Checking the input draw. Around 750 milliamps. Now I'm going to short the coil. Little bit of spark there. Shorted amps is just a little bit more than 500 milliamps. And the input is going down for the 800 mark. Give it some time for it to stabilize itself. There's the output, milliamps shorted. Say 500 milliamps. The input milliamps is now say 850 milliamps and stable, not going any further. So this one coil here behaves kind of the same as the first one I showed in the first video on my own design coils, which is the video title Future War Generator 1. That coil is different but behaves similar to this one. Input is still 850 milliamps, so it's stable now. Going back to the 5-watt load. Voltage is climbing a little bit. And the amp draw is back to 700 milliamps, which means that the system is speeding up a little bit back to its original stage when it was loaded with the 5-watt load. Now this coil, I don't remember how this coil performs at high speed, but maybe that's because I didn't do this test yet. I don't know. But looking at how it's performing, I think I'm gonna say that it should do pretty well at RPMs between 2500 and 3000 RPM. We will see. Input 715 milliamps at 18.1. Output 6.1 at 250 milliamps with a 5-watt load. Now I'm gonna disconnect all system. System is totally disconnected now. rotor is still going, of course, because there's no cogging effect. Still got a little bit of output, 5 volt at around 200 milliamps on the 5 watt load. Let's switch over to the 1.2 load. Still going, which is nice also. Soon I will show the high-speed testing of these 3 coils. I'm busy assembling my large pulse motor, which is the pulse motor where I do all my high-speed testing. Gonna give you just a short preview of it, and there it is. That's my large pulse motor. Some pulleys to get to the desired RPM. A large flywheel, large and heavy, and this is the motor side itself. Just putting it back together because, as you can see, it takes a lot of space on my workbench. There's also a DC to DC converter because I don't have a power supply. Anyway, that video will come. Be patient. Thanks for watching.